YUXING Limited engineered 3 top fire stoves with catenary dome for two 1080 cubic meter blast furnaces at Shandong Junction Steel, and design parameters are indicated below. Cold blast flow rate 3,300 cubic meter per minute. Using blast furnace gas only, check work made of 19-hole pressure and flow equalizing checker with hole size 25 mm. Specific heating area per cubic meter of blast 40 square meters. Checker weight per cubic meter of blast 1 ton. Air and gas preheated with usage of flue gas. Blast time 60 minutes. Hot blast temperature 1250 degrees centigrade. Two 1080 cubic meter blast furnaces were commissioned in July 22, 2012, delivering stable hot blast temperature of 1250 degrees centigrade. In March 4, 2015, blast furnaces shut down temporarily due to environmental protection policy. In June 23, 2015, YUXING Limited organized more than 20 influential steel producers, academic institutions, and design institutes to conduct site visits to these steelworks. Inspection results of YUXING top fire stoves are reviewed as follows. Point 1. Dome shell, hot blast outlet shell, T-joint shell, and stove proper shell are still working in good conditions. There are no phenomena of high temperature, redness, and burn through. This has proven that the engineering of stove shell, technical treatment against stress growing cracking, depth of shell, and support construction conforms to national design standards. Point 2. Checkers are still well placed. Surface flight, projection, and depression of checkers stemming from ignition loss unobserved. No sign of deformation and net shift cracks. This has shown even distribution of high temperature which the gas flows is achieved, and right quantity of checkers is selected. Point 3. Damages, deformation, spalling, edge, and corner damages, cracks of ceramic burner and normal bricks are not observed. This has proven that structure of ceramic burner and Norros refractory bricks adopted are engineered rationally. Engineering of ceramic burner and Norros conforms to requirements of high hot blast temperature and long lifetimes. Point 4. There are no damages to hot blast outlets of 6 assaulted top fire stoves. Point 5. Combustion chamber wall and catenary dome remain intact. Net shift cracks and contraction cracks due to shutdown are not found. Rational design and appropriate material selection for dome and combustion chamber have been verified. Point 6. T-joints of pipe system use new Type D structure as a complete replacement to the conventional T-joint design, which is vulnerable to damages and collapse due to irrational forces. New type T-joints have assured safe delivery of high hot blast temperature, stability, and long lifetimes. YUXING Limited entrusted specialists of Henan Metallurgical Research Institute to carry out tests of YUXING hot stoves for 600 cubic meter blast furnace at Hebei Austin Steel as per national standards of stoves. Test results have shown that thermal efficiency of YUXING top fire stoves reaches 83.5%. Danieli Corus, Siemens, University of Science and Technology Beijing, Northeastern University, Chongqing University, and Wuhan University have carried out fruitful research on YUXING top fire stoves by mathematical modeling. Presently, more than 370 YUXING top-fire stoves are being operated or under construction at home and abroad. In October 2012, YUXING top-fire stoves for 1860 cubic meter blast furnace at Shanxi Tongdai Steel achieved delivery of monthly mean hot blast temperature of 1314.7 degrees centigrade, with temperature difference between dome and hot blast less than 94 degrees centigrade. Strong performance provides technical conditions for delivering hot blast temperature of 1300 degrees centigrade. Highlights reviewed by YUXING top-fire stoves have attracted hundreds of steel producers and design institutes to visit steelworks where YUXING top-fire stoves are being operated. Specialists give quite positive assessments to YUXING top-fire stoves in terms of dome, hot blast outlet, ceramic burner, T-joint of pipe system, and checkers after the visit and technical seminar. Assessment of Professor Wang Xiaoliu. YUXING stove is superior to introduced top-fire stove. That of Professor Wang Weixing. High hot blast temperature delivered by YUXING top-fire stove contributed to high hot blast temperature of stoves in China. That of Dr. Teng Shushen. YUXING top-fire stoves is a step forward comparing to introduced top-fire stove. That of Tang Qinghua. YUXING stove and YUXING checker have proprietary intellectual property rights. That of Qian Sichong from Sougang. The most crucial feature of YUXING stove is the minor temperature difference between dome and hot blast during gas and blast cycle, and there is no dew formation and stress cracking, and therefore high hot blast temperature of 1300 to 1400 degrees centigrade can be realized easily. That from Danieli Corus, there is no pulse heating combustion in YUXING stove. That from Siemens, one of the highlights of YUXING stoves are the quite smaller temperature difference between dome and hot blast. It is believed that by far YUXING top-fire stoves are an international leading technology having China's industrial proprietary intellectual property rights. The crucial feature with hot blast temperature of 1300 degrees centigrade achieved and dome temperature less than 1400 degrees centigrade controlled has solved the technical difficulty of stress cracking of shell. YUXING top-fire stoves will be the most promising technology in future, which can be applied in medium and large capacity blast furnace, and surely make outstanding contributions to iron and steel industry concerning high hot blast temperature, energy saving, and environmental protection.